Okay, so we're going to do notes on factoring. And factoring is really kind of a way of looking at it is you're unfoiling. So what I mean by that is, let me get my pen ready, sorry. When I have something to FOIL, like 2x minus 4 times 5x plus 6, right? If I go ahead and FOIL that and I do my first, so 10x squared, my outer plus 12x, my inner minus 20x, and then my last minus 24. And if I simplify that to 10x squared minus 8x minus 24, that's what I typically do when I FOILed. So what we're going to do now is we're going to factor, which means we're going to take a trinomial, or it could be a binomial, or whatever we're looking at, and we're going to go backwards and try to figure out where it came from. So we're kind of unfoiling. So factoring can be looked at as unfoiling. There's 3 techniques that we're going to talk about. And the first factoring technique that you always want to use, no matter what type of problem you're doing, is look for the GCF first. It's the first technique you want to use. GCF stands for greatest common factor. If there's a greatest common factor, you want to pull that out before you do anything else. Okay, that always has to be first. Second technique we can use is DOS, and what we name that is it's a difference of squares. And when you have a difference of squares, it's what it sounds like. I have a minus sign in between 2 perfect squares. So an example would be like x squared minus 9. That would be a difference of 2 perfect squares. So as long as it's a minus and you have 2 perfect squares, you can factor by using DOS. The third technique will be what we'll use for any trinomial. Trinomials have 3 terms. Okay, if it has an x squared, I don't know what my mouse is doing. Stop. If I have an x squared, so like a 1 is a coefficient, we're going to do the multiply add method, which I'll explain in a minute. And if there's a number in front of the trinomial, sorry, I'm going to squeeze this in over here. If there's a number in front of the trinomial, so a number x squared, we're going to use the guess and check method. Let's erase that. Okay, so now the fourth method that we're going to do is at times you're going to do a combination, meaning you might just have more than one factoring technique to use for the problem. So you might do a GCF and a DOS, or a GCF and a trinomial. It just depends on what the problem's asking. All right, so let's go ahead and look at number 1. The first thing we always want to do is look for a greatest common factor. And if you look at number 1, they both share a factor of 4, meaning 4 can go into 4 and 12. I can't pull out an x because the second term doesn't have one. But if I pull out a 4, if I pull it out of the first term, I would do 4x divided by 4 is just x. And then negative 12 divided by 4 is negative 3. And the reason why I'm dividing is, think about it again like the unfoiling. If I were to go backwards and distribute, I would get 4x minus 12. So you want to be able to go backwards and get exactly what you started with. Now I can't factor that anymore. That would just be my final answer. Okay, number 2, if I look for a greatest common factor, I don't have one between 4 and 9, and this is x squared and this doesn't have any x's. I look for my second factoring technique, which is a difference of squares, and this sure is a difference of 2 perfect squares. When you have a difference of perfect squares, the way you factor is you take the square root of each of the terms. So you take a square root of the first, which would be 2x and 2x, and then you take the square root of 9, which is 3 and 3. And you're just going to put a plus in one of your binomials and a minus in the other binomial. So you take the square root of the first term and put it on the left side of the parentheses, so 2x and 2x, square root of 9 was 3 and 3, and 1 plus 1 minus. And again, you could check your answer by distributing throughout. 4x squared minus 6x plus 6x, so my x terms drop out, minus 9. So make sure you can always go backwards and get your original answer. All right, if I look at number 3, again, I'm starting with GCF. It looks like I can pull out a 3, but I also can pull out an x squared because both terms share 2 x's. When I make my parentheses, 3x cubed, if I took out a 3x squared, I'd still have an x left over. And plus 9x squared, if I took out 3x squared, it'd be plus 3. And again, to double check, kind of multiply through. All right, number 4. When I look at it, I might think difference of squares, but if you look, 2 and 18 are not perfect squares. But my first factoring technique is always to do a greatest common factor. And if I do that and pull out a 2, I'm going to get x squared minus 9. Well, now after I pulled up the 2, I should see, wait a minute, x squared minus 9 is a difference of squares. I leave the 2 out front that I pulled out. I'm going to make 2 parentheses, take the square root of the left term. So square root of x squared is x and x. Square root of 9 is 3 and 3. Make 1 plus and 1 minus, and I look further, but I can't factor that anymore. All right, number 5, I have 25 minus 16x squared. Even though it's kind of in reverse order, I still have a difference of perfect squares. Just be careful when you factor this to put it in the right way, meaning if 25 is the left term, then I want to put my 5 on the left side of my parentheses when I take the square root. When I have 16x squared, I want to put 4x on the right side of the parentheses and make 1 plus and 1 minus. So those are kind of examples of GCF and difference of squares and some combinations of GCF and difference of squares. Let's look at number 6. Now I have a trinomial, all right? I want to try to pull out a GCF, but I'm not going to be able to. I'm not going to be able to do difference of squares, so now I want to use one of my trinomial methods. All right, so the first trinomial method we talked about was if there's a plain x squared, meaning there's a 1 as a coefficient, we want to find out what 2 numbers multiply to give me 28 and then add to give me negative 11. And they have to satisfy both conditions. They have to multiply to give me 28, but also add to give me negative 11. So some of you are going to find the factors right away, and others will take longer, and that's fine. But keep playing around with numbers till you figure out what's going to multiply to give me 28 and add to give me negative 11. Well, 7 times 4 is 28. And if I do negative 7 and negative 4, that could add to give me negative 11, and a negative times a negative would be a positive. So I could do x minus 7, x minus 4. And it doesn't matter what order you do them in, you just need to be including them both. All right, and again, if I were to FOIL this, I'm going to get back what I started with if I did the problem correctly. All right, let's do number 7. Again, this has a 1 out front as a coefficient, so I can say what multiplies to give me 32 and what's going to add to give me 12. So what 2 numbers are going to multiply to give me 32 and add to give me 12? Well, let's see, 8 times 4 is 32, and if I do positive 8 and positive 4, that would give me 12. So I know the only way to get x squared is x and x. I'm trying to figure out my last terms and my middle term by using the multiply add, so I'm going to say plus 8 and plus 4. Okay, go ahead and try, or let's do 8 together, and then I'll have you try 9 and 10 on your own. Number 8, since there's a 1 as a coefficient, I'm saying what multiplies to give me 6 and adds to give me negative 5. Multiplies to give me 6, adds to give me negative 5. 3 times 2 would give me 6, and the way I could add those to give me negative 5 is if I did a minus 3 and a minus 2. X minus 3, x minus 2 would wind up getting me a positive 6, and I'm good. Go ahead and pause the video, try 9 and 10, and then come back and I'll work the next couple problems with you. All right, on number 9, I want to find out what multiplies to give me negative 6 and adds to give me negative 5. And I did this on purpose. 9 and 8 are very similar problems. The only difference is 8 has a positive 6 as a coefficient and 9 has a negative 6. When I multiply to give me negative 6 but add to give me negative 5, I can't use x minus 3, x minus 2. That would not get me a negative 6 when I multiply. What you have to use is a negative 6 and a positive 1. And that's going to satisfy the conditions of multiplying to give you negative 6 and adding to give you negative 5. And number 10, what multiplies to give me negative 27 and adds to give me negative 6? I should get minus 9 and plus 3. That way when I multiply, I get negative 27, but I add the 2, I get negative 6. All right, 11, 12, and I think 13 are going to be the trinomials with a coefficient out front. So meaning I have a 3 out front of my x squared term. So I can't do what multiplies to give me 5, adds to give me 8. That's not going to work when I do a problem with a coefficient that's bigger than 1 or just isn't 1. So what I'm going to do is I'm going to do a method just called guess and check. What's nice about a 3x squared is the only way to get 3 is 3 times 1. And the way to get x squared is x times x. For 5, since those are my first terms, right, this is for my first term, these are for my outers and inners, and this is for my last. The only way to get my last term is 5 times 1. So I'm going to do this. I'm going to go ahead and put a 5 here and put a 1 here. And I'm going to kind of multiply it out and see what I get, meaning I'm going to say, okay, 3 times 1 is 3x squared. I would get 3x here, and I would get 5x. If I have 3x and 5x, is there any way to get an 8x? Well, if I make both of these positive, that should work. So you can kind of go back and FOIL it. 3x squared plus 3x plus 5x. So that's 8x plus 5, and you're done. So I got 3x plus 5 and x plus 1. Let's do number 12. I'm going to make 2 parentheses because I can't do a greatest common factor. I can't do difference of squares, so I'm going to try my trinomial method of guess and check. To get 2x squared, I have to do 2 times 1. I know that. Now 15, I could do 5 times 3, and I don't necessarily know what order it's in, so let's try 3 here and 5 here, and work on your, what Miss Four taught me before was your OOIs. I'm looking for the inside and trying to find out, what my middle terms would be.
Sorry.
So if I were to FOIL this out, I would get a 10x and a 3x. Well, 10x and 3x are definitely not going to get me a negative 1. So that's just not right. So I'm going to go back to my eraser and say, okay, that guess and check didn't work. Instead of putting the 3 and 5 here, what I'm going to try to do is let's put the 5 here and the 3 here and see what happens. Okay. If I do it now, 2x squared is fine. I would get a 6x and a 5x. Well, I know 6x and 5x I could make into a negative 1x if the 6 was negative. So I need to make the 2x times 3 a negative. Hold on, I'm doing a lesson each. Minus here and plus here. So it'd be 2x plus 5 and x minus 3, and that'd be my final answer. On number 13, we're going to do a binomial and a binomial. Now, 4x squared, you could use 4 and 1, you could use 2 and 2, so it's going to be a little bit harder just because I don't know which one to choose. Go ahead and close it if you can. So if I try, let's say 4x times x and 5 times 3, if I'm thinking about doing my OOIs, like my inner and outers, I would get 12 and 5. Well, 12 and 5 is not going to give me 4. All right, so I'm going to give up on that one and say, okay, you know what, let me try. I'll leave the 5 and 3, but instead of 4x and x, let's try to do 2x times another 2x. So now my OOIs would be, let's see, 6x and 10x. Well, would 6x and 10x get me 4x? It would if this was positive and this was negative. So the 10x I need to make positive, the 6x I need to make negative. So my final answer would be 2x plus 5 and then 2x minus 3. So that would be my final solution. On 14 and 15, we're going to do, if you don't see it at first, but I'm going to do combinations. Oh, I already did. Just kidding. Don't do number 14. We already did that in number 4. Let's jump to number 15. On 15, I'm going to go ahead and pull out a 2 because they all are even, so I know that they can share a 2. So I'm going to get x squared minus 2x minus 63. I'm going to leave the 2, and then I'm going to factor my trinomial as what multiplies to give me negative 63 and adds to give me negative 2. Well, I know 9 times 7 give me 63, and if I make it, what, a negative 9 and a positive 7, that would get me a solution that would work. So let me just look back. Number 4 is really number 14. I kind of guess did that one preemptively. But you have 14 problems here that are mixed up methods. On your homework, look through your methods and make sure, or look through your problems and make sure you do a greatest common factor first, then your difference of squares, then a trinomial, then combinations. Good luck.